All right, good morning to everybody. Looks like we have about 13 people. We'll hold on here for a second, see if we get a couple more. As you guys can see, location has changed a little bit, no longer on campus. I was kind of worried that they were going to, no problem. Was worried they might shut down the internet and stuff, so I'm doing it from home. This morning's class, the 8:30, internet got a little bit glitchy at the end, so hopefully we don't have that issue here with you guys. But yeah, just going to be broadcasting here. So is everybody, back for some more, Stephen? So can everybody see the board and sound is okay for everybody? Get out of the way anyways. All right, so we got about 22. That's good. Let's go ahead and get started here. Good morning to all you cool cats and kittens. Today we are doing 8.1 and 8.2. Because of the limited board space I have now, on days that we have like this, like two sections we're doing, I'll just do the one, we'll do those problems, and then we'll do the other one. Although I don't think you guys had any, let me check the problems you had. I don't think there was any problems from 8.2. Maybe there was. I don't know. I'll have to double check, but I don't think so. But anyways, 8.1, so we switched to polar graphing. And polar graphing, with rectangular coordinates, it's our x and y. How many units left or right? How many units up or down? With polar graphs, we're dealing with r and theta. Radius, how far out from the center? Okay, question, yep. Sure, yeah, we'll do that. Just when we get to 8.2, just remind me of that. Then Eric, you have a question as well? The extra credit for this third test, like the previous, no insurance policy, nothing like that. So it'll just be you guys, on your own wits at that point. Okay, so for today, 8.1, we have r and theta. We're always going to move theta first. So if it's pi over 2, we're going to move to pi over 2. And then r tells us how many units out from the origin. If r is negative, we move in the opposite direction of theta. So it actually put us at 3 pi over 2. And then for converting from polar to rectangular or rectangular to polar, we're basically going to be using these 4 equations. And honestly, more often than not, we're going to be using these 3. We don't get into the tangent of theta too much. But anyways, we have x is r cosine of theta, y is r sine of theta, r squared is x squared plus y squared, and tangent of theta is y over x. Again, all this was on the videos. It's just kind of, I guess if you guys are creating a cheat sheet, or I guess we don't have to call it a cheat sheet now, maybe a reference sheet, because your test will essentially be open book, open notes. You're going to have access to it as you're there at home. So this will just be so you don't have to search all over the place for the information. So I'm going to go ahead and erase this. If you guys need it later, you can always rewatch the video. So any questions on the graphing of the polar coordinates? I know that sometimes gets a bit confusing. So before we get into the problems that you guys wanted to see, is there any questions on that stuff? While you guys are potentially typing, I'm just going to double check what questions you guys wanted to see. Let's see, discussions. So 1, 6, 14, 15. Okay. Won't have open notes for the final. So you guys are not going to be using Proctor U. I think I need to update that maybe. 1 to 15, yeah, that's similar questions. So ProctorU charges for every student. So I won't go too much into it here, but they charge for every student that uses the service. And so because you guys weren't charged that ahead of time, they can't, the school, UNLV, can't come back now and charge you guys on the back end to use that. So your final exam, I'm going to check with the coordinator today and see what his plan is. So your final exam is probably going to be like the Canvas quiz like you guys just took for exam 2. It's not going to be done through ProctorU. My office mate is actually looking into a proctoring service out of Toronto, and they said that they would do it for free. So we'll kind of have to see what their capabilities are, but that might be the option besides ProctorU, but it definitely won't be ProctorU because you guys haven't been charged for it, so they're not going to do that. So glad you brought that up. All right, so number 1, and again, so I know some of you guys are asking these questions. Ideally ahead of time, if you guys can post it on the discussion thread that's on Canvas, post a screenshot of the problem. Because again, I can pull up my WebAssign, it'll show me what the problem is, but it doesn't have your numbers on it. So rather than trying to type it in the comment box here, it can get a little bit crazy. So number 1, we have 7x equals 7y. We need to convert this to rectangular equation. So rectangular equation means that it can only have a r, a theta, or numbers in it. So no more x and y. So we want to try to use some substitution of those equations that I put on the board to eliminate the x and the y. So before we do that, how can we simplify this problem? 7x equals 7y. What's the first thing I can do here to make my life a little bit easier? Yeah, number 1 wants, they want it to convert to polar equation. So yes, Kenneth, we're not going to square it, Stephen. So I'll give you guys a hint here. The easiest thing I can do is divide both sides by 7. So I just get, there we go, Natalie. I just get x equals y. Now, as Kenneth had mentioned, now I can use my substitution. So I get x, which is r cosine of theta, is equal to y, which is r sine of theta. Now what can I do to make my life easy here? So to simplify this equation, what can I do? Exactly, divide by r. So a polar equation is typically going to be r equals something. But in this case, we've eliminated the r. So I'm just left with cosine of theta is equal to sine of theta. So now I'm going to divide both sides by cosine of theta. So when I do that, I get what? I get 1 on the left side. And on the right, I have sine divided by cosine. Well, sine divided by cosine is what? That's tangent. So this equation is really just saying tangent of theta is equal to 1. So where on the unit circle is tangent of theta equal to 1? It's when theta equals what? So where is tangent of theta equal to 1? Exactly, pi over 4. So that would be the final answer. That's what you're writing in your answer box. Theta equals pi over 4. Because remember, ultimately, these two equations, the one that we started with and the one that we ended with, have to be the same. They have to represent the same thing. Well, this one, 7x equals 7y, which is x equals y, or maybe better off, y equals x. What does the graph of y equal x look like? it is the dotted line, or it's the line that goes through the origin at a 45-degree angle, which if I draw theta equals pi over 4, it's what? It's the diagonal line at 45 degrees going through the origin. So that would be your answer. And so, Stephen, your point, it is 5 pi over 4, but because this goes on infinitely, that starts picking up this 5 pi over 4 from quadrant 3 as well. Yeah, so if we just say theta is pi over 4, if r is positive, it puts us in quadrant 1. If r is negative, it puts us in quadrant 3. So that's the only equation that we need. All right, questions on that one? Let me just double check again which ones you guys needed. Okay, 5. All right, so number 5. And again, remember, if you have a question, just type the exclamation point so that I stop before I get too far. Then go ahead and type your question so that I don't get too far ahead of you and you're still typing. So, all right, number 5, it wants us to convert rectangular to polar. We have negative square root of 6, negative square root of 2. So using those formulas that we have, we need to find our value for r, and we need to find our value for theta. So we have what? R squared. So this is my x, this is my y. So r squared is x squared plus y squared. So those two guys there. Simplify this, we get r squared is 6 plus 2, which is 8. So r squared is 8, so r is just square root of 8. You don't have to simplify it, you can just leave it square root of 8. Questions on that? Now theta. So our equation that we have is tangent of theta is y over x. So negative square root of 2 over negative square root of 6. I have no idea where this is on the unit circle, but simplify it and rationalize it. We have negative over negative, so that makes this whole thing positive. And by our square root rules, we can put this whole thing 2 over 6 under the radical symbol. Simplify this becomes 1/3. And now with our radical rules, break it apart again. This is square root of 1 over square root of 3, which is 1 over root 3. Rationalize it is square root of 3 over 3. So this whole equation is really saying tangent of theta is square root of 3 over 3. So now I ask you, where in the unit circle, there's 2 places, is tangent of theta equal to root 3 over 3? All right, so 7 pi over 6. And what else? Not pi over 3, not pi over 4. Oh, pi over 4, I think was the last problem. Yep, pi over 6. So I have 2 possibilities here. So my polar coordinate is square root of 8, that's the r, and then theta. Since I have 2 values, do I just pick whichever one I feel like, or does it matter which one I pick? Well, the answer is always what? It matters. And so in this case, how do I know which one to pick? I have to go back to the original point. Again, these 2 coordinates have to map to the same location. So negative root 6, negative root 2 is in which quadrant? So if x is negative and y is negative, it puts me in which quadrant? Not 4. So negative, negative. Exactly, quadrant 3. So which of these thetas is in quadrant 3? It's the 7 pi over 6. So 7 pi over 6 is what needs to go in my answer for the polar coordinates for this problem. So questions on this one? No? All right, I'm gonna go ahead and erase it. Again, this video will be up on YouTube, so if there's something that doesn't make sense, you can always go back and rewatch it. All right, number 6. Number 6, we have y equals 6x squared. So we need to convert this from rectangle, x's and y's, into polar, r's and thetas. So use the 4 equations that I gave you at the start on the board to try to simplify this one so that it ends up an equation r equals something. Now, before you start working this one, because I can't take attendance, and so I don't know who's actually doing what they're supposed to do, which is checking into these videos, following along, asking questions if you have some. What I'm going to do is each day, each class period, is I will pick a problem that you guys want to see, and I'll call it the attendance problem. So in your ticket out the door notebook for 4-2 for today, the first problem you should have in there is this one. Problem number 6 from the homework. At the end of the videos here, I'll give you ticket out the door problems like normal. But at the end of the semester, when you guys turn in your ticket out the door notebooks, or if you have to email it, depending on what happens here, but ideally, you'll be able to drop off your notebook and I'll be able to grade it. And what I'll do is I will look for these problems. So on 4-2, I'll look for this problem. On 4-7, I'll look for that problem. On 4-9, I'll look for that problem. And that will make up your attendance grade. Because obviously, I don't want to take attendance now. Some people might not be able to log on right now. Maybe they watch the videos later and go to the questions they have an issue with. That's fine. But this is your attendance problem. So put this in your ticket out the door notebook for today, 4-2. And then at the end of class, I'll give you a couple more problems to do that. So go ahead and work this one. Once you guys get done with this problem, we put the problem first. Yes, exactly, Sydney. So this will be your first problem for ticket out the door for today. And just put like attendance next to it so that I know when I'm looking through, I can see, okay, these, they were logged into the video for this day. So I'll give you credit for attendance for today's video. So go ahead and try this. Once you guys get done, just type done so that I know that people have finished up. That way I'm not just sitting here wasting your guys' time. So try this problem. If you have questions on the problem, certainly go ahead and type that in as well. I'll try to help you as best I can. But otherwise, try this problem. Once you have it, just type done. Okay. And again, you want to try to, okay. And so that actually brings up a good point. If you get stuck and you can't go any further, just type done as well. So I know that you're done working it maybe. Or if you think you have the answer, that's fine. Again, remember, ultimately for this one, we want an answer R is something. So that should sort of be what you're trying to do, okay? So we got there 6 of you. So it looks like 27 of you guys logged on. So just let me know when you're either done with it or just done working it. So, okay. All right. Looks like you guys are wrapping it up. The majority of you are anyhow. So first thing we're going to do, we need to get our R's and our thetas into the problem. So we use that substitution. So Y is what? It's R sine of theta. And X is R cosine of theta. But the whole piece, because of the X squared, the whole piece gets squared. So if I bring in this square to both of these pieces, I have R sine of theta is 6R squared cosine squared of theta. So now, ideally, I want R equals something. So I could leave the R here and divide by sine, but on this side, I'd have to divide by R squared, and now I don't get R at the end. So if I just divide everything by R, that leaves me with just one R here on the right. So 6R cosine squared theta is equal to sine of theta. Now to get R by itself, divide everything by 6 cosine squared. So that means we have R on the right. And on the left, I'm going to use that little trick that we used with the simplify and the proof problems, which is to break this whole thing apart. So this is really like 1 over 6 sine over one of the cosines. And then I have one more cosine left, so 1 over cosine. So what this guy ends up being, I'll just move the R over. So R is equal to 1/6 sine over cosine is tangent, and 1 over cosine is secant. So this original equation is the same thing as R is equal to 1/6 tangent of theta secant of theta. Questions on that one? Again, if you have questions, that's fine. Just hit the exclamation point so I know you have a question, and then go ahead and type it out, and we'll just wait on you. All right. So number 7. Number 7 is a little bit tricky. I'll be honest with you. So number 7 used to be an exam problem. I don't know if I'll be able to have it as an exam problem anymore. It's going to be hard to give partial credit. The formatting, the answer could be a complete mess. So I don't know if I'll have it. If it is, of course, I'll tell you that it's going to be on the exam. But it's a good problem. It's just really difficult to do in that online version. So, all right. So we have R equals 16 over 1 plus 4 sine of theta. So with this problem, it's the same steps that we always follow through. Again, we'll do this problem, and then if it ends up on the exam, we'll make sure we do one for review. But right now, I got to figure out if there's a way to do it. Well, the first thing we're going to do is multiply both sides by the denominator. So when I do that, on the right side, the whole denominator is gone. So all I have left is 16. On the left side, distribute the R. So I get r plus 4r sine of theta. So I'm trying to make these substitutions. I have one that I can make here. R sine of theta is equal to what? What substitution can I make here? R sine of theta. Everybody still here? Yes, it's equal to y. So this can really be rewritten as r plus 4y equals 16. So now, the only thing I have left is an r. Yep, okay, good, you guys are getting it. So the only thing I have left is an r, and the only equation I have that has just the r is an r squared. If I try to square both sides at this point, I'm going to end up with a big mess. What I need to do first is get r by itself. So I'm going to subtract 4y from both sides. So I get r equals 16 minus 4y. Now I can go ahead and square both sides. So on the left, I get r squared. And on the right, be careful here. Going back to Math 126 and our binomial theorem, if I have a binomial that's squared, I'm going to end up with how many terms? 3. So this is really 16 minus 4y times 16 minus 4y. So if you FOIL it, you get 256 minus 128y plus 16y squared. Lastly, make one more substitution. We have what? R squared is equal to x squared plus y squared is equal to this whole guy. And technically, you're done. You've converted the entire equation to x's and y's and numbers. So you should be able to put that into WebAssign. It'll take it correct. Now, the problem is that this is why this problem is an issue for me to write as an exam, because I would have to have you guys format it in very specific ways, and it might just get real messy. But otherwise, this is your answer. Or what I'm going to have to do is write an exam on WebAssign. That might be the other option. But otherwise, that's it. That's your answer. You've converted everything to x's and y's. Any questions on that one? Back here real quick. All right, so next one, number 10. So 10 is this whole idea of plotting polar points, and they can have multiple listings for their values. So you're given 4 and pi over 2. You can do that, Jay. Yeah, you can. And so maybe, like that's maybe one way that I could do it as an exam problem. But again, if you switch up the order, then all of a sudden it becomes a problem. So WebAssign handles it nicely. Canvas doesn't. But yeah, if you move everything equals 0, that's fine. It should still give you the right answer. All right, so let's plot this point first. So we always move theta to begin with. So that's pi over 2. That puts us here on the top part of the y-axis. And then the radius is 4, so it's 4 units out from the center. So this point is located right there. Now, the first thing it wants is another listing or another description of this point, but with r is less than 0. meaning it's going to be -4 and some theta value. So now remember what a negative radius means. It means we're going to move to some theta location and then go the opposite way, which means that if from where we stop, we have to go the opposite way to end up here, means that we have to move to this location here. And that theta is what? That's 3 pi over 2. And then -4 means go the other way, which puts us back up at that point there. So 3 pi over 2 would be our value. Exactly, Jonathan. Perfect. Yep. So we're moving first 3 pi over 2. Always move theta first. And then -4. So don't come this way, go the other way, which puts us back up at the top. Perfect. The second part of this is r is greater than 0. So we're still going to end up with 4 as our r value, which means that we have to get to a theta that puts us here. Yes, -pi over 2 would also work, correct. So we want to get to this theta direction going this way. So when we move out 4 units, we're here, and we have two options. If theta is negative, it would be what? -3 pi over 2. Or the other option is what? Well, we've already moved pi over 2. If I go all the way around the circle again, another 2 pi, that will put me back at that spot. So it's what? Pi over 2 plus 4 pi over 2. So 5 pi over 2. And there is an infinite number of these answers. So you could have 5 pi over 2. You could have 9 pi over 2. You could have -3 pi over 2, et cetera, et cetera. Any questions on that one now? In the meantime, I'm going to jump back over here, see what else. And so number 12 is the same idea, just a different point. All right, last one from this section then is number 14. So you have x squared plus y squared is 36. Let me make sure this is the last one. Oh, 15. Oh, 15 as well. So we'll do 15. 14 and 15. Okay. So we want to convert this to polar equation, meaning we want only r's and thetas and numbers. Well, x squared plus y squared is the same thing as what? With our substitute equations, r squared, exactly. So we can change this whole thing out to be r squared, but I want the equation to be r is equal to something, so I have to do what? Square root both sides, so r is equal to 6. That's it, just r equals 6 for that one. Any questions on that one? This is one of those essence of math. This is one of those essence of math. Make complicated things simple, not simple things complicated. So try not to overthink that one there. 15, r equals 7 cosine theta. All right, so 15. R equals, was it 7 cosine theta, I think I said? Double check. Yeah. All right, so we have this guy. We need to convert this one to rectangular. So I want to get rid of the r's and the thetas. I want to put in x's and y's. So I have an r. If I square both sides, is that going to help me? And the answer is no. It would help me on the left, but not on the right. So what's another way that I can get an r squared on the left side so that I could make that substitution? What can I do to this entire equation? Okay, that's fair. Yes, so as you guys are saying there, we're going to multiply the entire equation by r. So multiply this side by r, multiply that side by r. So I get what? R squared is 7r cosine of theta. Yep, perfect, you guys. And r squared is what? That's x squared plus y squared. R cosine of theta is what? It's x. And again, technically you're done. You could move everything over if you want. X squared minus 7x plus y squared is 0. If you want to do that, that's fine. But web assign should take either of those versions, I'm assuming. All right, so any questions on any of this before we move on to 8.2? All right, so 8.2 is your polar graphs. And on Canvas, under the File section, I put a file is called, and I should have told you this before you did these problems, but it's called Polar Graph Shortcuts. And essentially, all you have to do is take the values for A and B, and it tells you how far the tip, how far the sides, how far the loops, how big are the leaves, how many leaves do you have, things like that. So it takes all the math out of it, really. It's just you figure out these couple of values and then you know where to plot your points. So Stephen, you had asked me earlier for one of the questions. Do you want to tell me that again? Which number was it? Feel silly, didn't even think. Yeah, it's one of those like afterwards. It's like, oh yeah, why didn't I do that? So. Because we're so used to thinking, oh, I need to square everything. The flower, do you know which number it was? Let me see. Okay, sine of 6 theta. Okay. All right. So, which one was that? Number 2? Oh, number 8? Okay. So sine of 6 theta. So if we look at the, r equals sine of 6 theta. So if we look at the shortcut sheet, rather than try to plot all this out, the first thing is we have to figure out what type of figure is this. Well, there's no plus or minus, means that this has to be a rose. Second is how many leaves do we have? So number of leaves, and it depends. So this is my value for n. So n is 6. If n is an odd number, we just have n number of leaves. If n is an even number, like we have here, it's 2 times n. So 2 times 6, so 12 leaves. That makes sense to everybody. And again, if not, just hit exclamation point so I stop. Now, we have 12 leaves around the entire unit circle, so what's the angle between them? It's simply just 360 degrees, the whole circle, divided by how many leaves do we have? 12. So this is what? 36 divided by 12 is 3. So 30 degrees between every leaf. So they're stacked right on top of each other. And then lastly, where do we start? So with cosine, it always 100% of the time starts at 0. The first leaf would be out at 0 radians. With sine, it's a little bit trickier. It starts at pi over 2 times n. So in this case, our n is 6. So the first leaf we have starts at pi over 12. Pi over 12 is half of pi over 6. Pi over 6 is 30 degrees. So if we want to put this in terms of degrees, this is starting at 15 degrees. So basically we have one leaf, and then the length is the number in front, 1. So at 15 degrees, we have our first leaf. And then add 30 is 45. And then add 30, 75. Then add 30, 105. Add 30, 135, and so forth. So it's going to be a 12 leaf rows. Now I'm using up all my ink. That looks something like that. So it doesn't start at 0. It turns the whole thing by 15 degrees. So that's how you would do that one. That's how you would do a rows problem. Does that make sense? Any questions with that one? No? All right, so what time are we? 10:45? All right, let me give you guys your ticket out the door problem then. I'll bring Cash in. You guys can meet him today. Yep, you're welcome. So for these problems, take it out the door. I'll put them on the board. I'll give you guys a couple minutes to work them, or whatever. We got half an hour. I'll give you time to work them. That way, if you have a question or there's confusion, you can ask me about it here. Otherwise, I'll give you guys the answers, because that's my bigger concern, is that you guys have the answers so that ideally you go back and try these problems and hopefully figure them out. So, and at the end of the semester, I'll still be doing the ticket out the door videos. So if for some reason my explanation later doesn't make sense, hopefully the video later on would. So ticket out the door number 1, sketch R equals 2 minus 2 cosine of theta. And number 2, sketch R equals 2 minus 3 sine of theta. Have you guys write those problems down. You can try to work those. Like I said, once you get them written down, I'll call Cash in here so you guys can meet him today. Maybe Ginger on Tuesday. We'll see about Bambi. She's a bit camera shy, so I don't know if she'll want to make an appearance, but maybe we'll just pick her up and carry her in here. So, cool. So can everybody see those okay? Last class, they had trouble seeing it at the end, but I think it was more the internet connection last time. Thankfully, it's held up here for us. All right, let me get Cash. Cash! Come here, bud. Cash? He's like, oh no, not again. Come on in, they want to meet you. Hey, hold on. Here he is, my old man with the frosted face. Turns 11 this year. Can you say hi, bud? Cash, look up here. There you go. Okay, back to sleep. Go ahead. Oh, now you want to stay? Oh, okay, you can stay. I guess he doesn't want his nap. How about whoa, that was a big shake. Want to go back to take your nap? Okay, go ahead. No, you're gonna stay? Okay, I guess he's staying. Yeah, he's a cutie boy. He's a good boy. Huh? Are you a good boy? You are a good boy, huh? Oh, handshake? Thank you. Yeah, so go ahead and try to work this problem. If you have questions, you have issues, like I said, after a few minutes. So if you get done and you want to put done, he is 50% boxer, 50% pit bull, 100% cuddle bug. So everybody's always afraid of pit bulls, but he's the biggest cuddler that we've ever had. So come on. You cuddle bug? Hey, what are you looking for? Cutie boy, huh? Yeah, so if you finish this problem or you think you do, if you want to put done, then that way if I know a bunch of you guys have it done, I'll go ahead and sort of work it out on the board, make sure you have the answer. And if you have that shortcut sheet that I had put on Canvas, that might help you with this problem as well. Then you're not having to sketch out the curve or plug in numbers, any of that. You can just kind of follow the steps. Hey, what you doing? Hanging out? Yeah. How's your nap? Good? Yeah, mine too. I have a little sign in the kitchen that says, dogs are not our whole life, but they make our life whole. And that's true. Although these guys are pretty much my life, so I work hard to give them a better life. That's what they say. Right, bud? You have a good life? Just eat and sleep. Bark at the kitties. Don't bark at the kitties. Sounds like Ginger's outside. Hey, Ginger, you want to come in and see the class too? Watch out, bud. All right, here comes Ginger. Come on, sweetie. Hold on. So, here's Ginger, my husky shepherd. Yeah. Okay. You lay down. All right, watch out so you can close the door. All right, see you later. They're not very interested in math, apparently. All right, so let me work this one for you guys. So this first one, it's a minus. We have a plus or minus sign. Yeah, this is the best class ever. Plus or minus sign means it has to either be a cardioid or a lemacon. Because the numbers are the same, this means it's a cardioid. Next thing, cosine. That tells me it's either pointing left or right. Because of the negative sign, that tells me it's a heart pointing towards the left. So now I just need to figure out all the pieces. Where's the tip of this heart? Well, I just add these two numbers, 2 plus 2, so 4. The sides, it's whatever this first number is, 2. I always have the origin as a point. So if I sketch this, it's pointing to the left. The tip is 4 units away, so out here. The sides are 2 units up and down because this thing is pointing sideways. And then I always have the origin as a point. Now let's connect the dots. I get a heart pointing over to the left. This reminds me, did anybody in the video I tell you guys like text your sweetheart? What is it? R is 2 minus 2 sine of theta, I think. Did anybody do that? And then maybe your significant other dropped you because they thought you'd gone off the deep end. All right, this one. Numbers are different, so this means it's a cardioid. I'm not a cardioid, a lemacon. So we do the same sort of math. Add the numbers for the tip. Oh, sorry. So first, which way? Sine is either up or down. The negative sign tells me that I'm pointing down. Yeah, I would suspect so. I actually had quick short story, and then I'll let you guys go here. A couple semesters ago, I had a husband and wife. The husband took my class one semester. His wife took the class the next semester. So the first semester, he sent her that sine 2 sine of theta. She thought he was nuts. And then, of course, the next semester, she did the same thing, and then they had a big laugh with it. So. All right, anyways, the tip for this lemacon, add them together. 2 plus 3 So 5. The sides, still just this first number, 2. Still have the origin as one of my points. But here, the lemicon is a heart with a loop. So I subtract these two numbers now. Bigger number minus the smaller. 3 minus 2 is 1. So if I draw this, so it's a lemicon pointing down. The tip is 5 units away. So down here, the sides are 2 units to the left, 2 units to the right. Don't forget the origin always. And the loop is 1 unit towards the tip. It's going to be inside. So now go ahead, connect the dots, make a heart with a little loop on the inside. Should look something like that. Thus my word sketch. It's not going to be perfect. I don't expect you to get out a compass or something like that and make this thing the perfect heart or the perfect lemicon. So that's really about it. So there's both of those problems. That's your ticket out the door for today. If you guys don't have any other questions, I will let you get on with your quarantine life. Be safe. Hopefully this thing gets over soon, not April 30th. Couple things. There is an assessment due on Sunday. So I will post that on Canvas as well, just as a reminder. And I'll also post a thread just to get some feedback from you guys, like how you think this is working. Is it working? Would you rather do like WebEx or something? At least with WebEx, you guys could talk to me. That would make it more enjoyable for me. I kind of hate this one-way conversation where I'm talking at you guys. I prefer more interaction, but it is what it is right now. So other than that, yeah, I guess if you guys don't have questions, have a great day, have a great weekend, and we will talk to you guys on Tuesday. What do you say, bud? Ready to call it a day? Oh, can you post the assessment? Or the assessment will be live or available tonight, and then it'll be due on Sunday. So at midnight tonight, I think it'll be available. Yep, you're welcome for the dogs. Little spirit lifter there, hopefully. But yeah, so it should be available to you guys tonight at midnight, and then due Sunday at midnight. So other than that, thank you guys, and we will see you soon.